Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be mechanical loads. We have basically two types of loads. We have these mechanical loads that we are going to talk about in this video, and we have the thermal loads, which we will see in the next video. So starting with the mechanical loads. These are a type of loads that are used when we are modeling studies of linear and nonlinear static analysis of structure strength. We have a lot of different types of calculations. We can include also buckling loads and cyclic loading, where we can take in account the fatigue. We'll try to see briefly the different types of loads that we can apply to our models, but it is very important because you can check all the videos we have with examples, because there we cover, I would say, the vast majority of different cases and examples, and there you can see in all the different cases how to apply the forces, the directions, how to choose the parameters. So it's a very valid mean for your understanding of all these types of topics, and among them also the loads. So I've created a very simple solid just to be able to apply the loads so that we can check how to do it. So analysis, we will create a new study. I will create a static strength study, choosing the solid. Really don't care about it in this phase. I will leave the mesh size, so not very important. And now loads. So loads, we have in terms of mechanical loads this item here. We open a lot of them. So the first one is the most common one, call it the force. So, and we open, we are able to supply all the parameters. So the force is a type of loading used to specify a concentrated load, and also for specifying a total magnitude of distributed load. We can supply faces, edges, vertexes, so we can choose here the element, so we can choose a face, we can choose an edge or a vertex. So for example, a vertex, we can mention which is the direction. I can use this direction, so you see that I have this graphic view of it. We can give the value, for example 100, and we can say, clicking here, the units among all of these units. So I will leave newtons. We have a visual scale that allow me to have this graphic view bigger or smaller. I will leave in 1. And we can have also local coordinate systems to apply or to have in consideration for the study. So when we have all of these, simply accept, and the conditions in terms of loads are applied. We can go to the study, and loads, we can open them. It's another way of having the parameters, and to open the parameters a little bigger than on this side, so we have all the items here. So, and we can edit these conditions. So this is the basic one. So this is a uniform distribution of the load. We can have also a non-uniform distribution, also in terms of force. So when we are choosing distribution, we can choose a non-uniform distribution. We can apply this, for example, in one face. So, and we can give a value here. we can give a direction, for example, okay, and we can have a distribution done in terms of nodes. So we can have kind of a matrix where we can apply these values. So we can say, for example, 3 by 3, and we can have, for example, let us say 10, this one, so 10, I want to say 10 also here, and I want to say 5, and if you can see, I have this it is a little big, okay. We can have the visual scale. Let me try to check and put this in. Sorry, I'm not sure if I can have the scale done. Okay, I open the window on this side. Maybe it's a little easier to follow here. Okay, a little smaller now, and we are able to see. So we can apply values to each of the nodes, this matrix 3 by 3, and we will have a distribution of the force among these points with this kind of configuration. So these are the grid points. We can have also an interpolation which can be linear. That is the case that I'm showing. But we can have also a spline distribution in terms of the appliance of the force. Okay, we have a couple of very nice examples among the videos that I mentioned already in terms of this distribution, so I think they explain exactly and show different kinds of cases and these uniform and non-uniform examples. Then we have a different kind of load called the pressure. Some of the conditions are very similar, so we can apply this pressure also in different elements. And we can have, for example, we can make a distribution uniform, also non-uniform, or we have another one called hydrostatic. So this is interesting. And this pressure represents a loading type to specify a distributed load. Okay. The principles are the same, and now I leave. I must go there again. We give value, we give units. We can choose also local coordinate systems and the direction of what we are applying, choosing the directions if it is the case. Pressure, we will give a couple of different conditions, being uniform or non-uniform, but the main difference and the most interesting one is this hydrostatic, which allow us to make a special case of a non-uniform load, which an example is the pressure of a liquid in a specified vessel. I don't have it ready here, but it's good to mention this thing. We need to supply the density of the liquid and its units, and also the direction of load. Okay, if we have a vessel, so it is more heavy in the bottom than on top, and that is the direction that we need to supply. So we have also some nice cases about this hydrostatic pressure, so it's you should watch those videos. Then we have something called the rotation, that it's to calculate the centrifugal force, and it represents a loading type used for simulating a centrifugal force, which arises upon uniform or non-uniform accelerated rotation of an object. So it's quite easy to mention the data. Basic an axis of the rotation. We need to give the angular velocity and acceleration with the units also. We can say the element is this one, velocity we can say 5, acceleration let us say 1, and we have enough data to create the calculation. For sure, this is not the most common element to make this kind of calculation, because usually we are talking about round items in rotation, but this is an example how to apply this kind of load. Then we have another one, acceleration. It's more or less the same, and this acceleration creates a uniform impact on any body with a mass. This impact is uniformly distributed over all the volume of this selected body. And for example, we can simulate the load of the own weight under the force of gravity. So we can make this kind of calculation. It's basic. So the element, the value, we can say, for example, 5. We can say the direction, for example, one direction, it doesn't matter. And we can have the calculation also done under these conditions. We have a simulation of gravity. So we can have the body, we have the acceleration of the gravity, the value, and we can say which is the direction also, and it will calculate the force of gravity on a body. I will change my model now because, and I need to create a new study just to show you the next one. Let us calculate. This is the same, a little rough, but for the example it is enough. We have this bearing load or bearing force, which simulates the load that occurs under impact of parts as an axle, a bearing, or shaft. A cylindrical face is used as a location to apply the load. Okay, and for example, we can say we can first apply the force under a sinusoidal law. Okay, we don't have any more options. So the direction, first the body is this one, the direction can be I don't have other direction here, so this is not the correct one, because usually we want to apply not perpendicular in this direction, but against radial. So let us say this one, and we have this kind of condition that again in this particular case it is not the correct one, but as an example I think it's enough to mention it. We have also the torque, and the torque it is represents the impact of a force moment which is distributed over a selected face. So we can say this face here, we can say the x is this one, and as you can see, let us say it is 100. We have the units also, Newton meter, and we have something like this. So it's a torque. We could apply opposite torques, one in this face and another one in that one, and will make a torsion shaft in here. We have also some nice examples about this this torque possibility. We have a couple of possibilities also. This one, additional mass, remote force, remote torque. These are variations of the above, so I will leave this behind. I want to end this with this one, oscillator, which is a kinematic load type. So I need to create a new study, and I will clean this one. Still here, so delete. Okay, and so a new study. In this particular case, I will not use this static strength, but the dynamic one. For example, the forced oscillation. The body is this one. I will accept. We'll create again this this mesh, and this oscillator type. It's a type of loading used in dynamic analysis studies. So the three that we have on the list. And we use them to specify the so-called kinematic excitation of vibrations. So it is possible to specify the displacement of a structure or its elements according to the arbitrary time graph. So we can use a graphic to make this thing. So we can have a lot of different types. So oscillator. So we can say this body, we can choose a coordinate system. We can have the type, which can be a study that will study the amplitude, the velocity, the acceleration, or the overload. So, and we can apply these values in any of the axes. And another important item is the shift, that being an oscillation, it will have a shift which the user can specify along with the units. So these are different types. Again, you can see or you are able to see all these examples in our videos, which for sure will help you a lot in understanding all these possibilities of what we can study with these calculations. I hope that all the topics that we mentioned in this video, and again all those examples that we have also published, will help you in taking a big advantage in the use of this analysis model. Anyway, besides all of that information, and also the information that we have inside the theoretical course, you can reach us for any support or help that you may need about these and other topics for sure. So anything, let us know.